Good evening and a warm welcome to this induction program for National Clean Air Mission program. At the outset, let me thank the World Bank Group, Ms. Karin, the IITs, iForest, NKN group members and Director NEERI for giving me opportunity to talk in this first technical session of the induction program. I'll be talking on urban air pollution management and how to develop city action plan and stakeholder engagement on it. Let me start with the overview. I'll be providing information on what is the consequence as a result of air pollution in an urban developmental area, how to estimate the non-compliance aspect to the ambient air quality for an urban area, identification of sources for air pollution, that is through emission inventory of point area line, and again through another technique called the source apportionment study through particulate matter and its composition. Some case studies as a result of the source apportionment studies, air pollution control challenges in city action plan delineation, stakeholders' roles and responsibilities, some pilot demonstration case studies on air pollution mitigation. Now, what happens when an urban area gets developed and the consequence of air pollution in it? Now, let us imagine a core area that is an urban area, the white portion as an urban area and the green portion as its surrounding area. So, what is this white portion? It is a core area where the sources of pollution are there, like we have residential, commercial and vehicular movement in this. We have all sorts of fuel combustion that takes place because of these activities. Now, these activities create a lot of air pollution and other environmental burdens on the urban area, and this is surrounded by buffer area. It is nothing but vegetation, some plain area, fallow area, then water bodies, then green vegetation, agricultural activities and other activities that surround the urban area, which helps and acts as a sink, and its function is to do the dry and wet deposition of particulates and gases, soil and plant interaction, atmospheric conversion and chemical reaction as far as air pollution is concerned. What does this core area contains? Core area, as a result of its urban activities of point area and line. Point are the small, medium and large scale industries that emit large amount of pollution at an elevated height. Area sources are the domestic combustion in restaurants, in hotels, in houses and other areas where the domestic combustion take place. These are the low level of air pollution that goes in this area. The others are the vehicular emissions that goes as a line sources. About kilometers of emissions are coming out both at low level and at high level in flyovers. Combined together, we have very high level of air pollution in this urban area as it is ever expanding and the buffer area gets reduced. So, what happens? The calm conditions, meteorological conditions where wind speed is very low is prevalent, and this gives to low level of emissions rising from these activities, temperature inversions, high buildings and narrow lanes, then congested roads, etc. leads to high amount of air pollution in this area. This area, if we consider in a city like Delhi, which is expanding and the buffer area is reducing, we can find smog, and that is phytotoxic chemicals such as ozone and pan, which are produced because of photochemical interaction. Now, such smoggiest cities, if we see around the world, then we can see that about many are there. I have listed about 15 such cities. These cities have a typical characteristics. They are more than 500 square kilometers with a very low buffer area. Similarly, if we see some of the cleanest cities in the world, then we can see that these cities are less than 200 square kilometers as the built up core area, and the buffer area is very high. So, what does we learn from this? We learn that there is a need for diagnosis of air pollution in such cities. There is a need to rationalize the core and the buffer zone activity. We should provide high buffer to core ratio, always maintain it, identify the hotspots of air pollution emissions, and provide clean fuels and alternate energy, pollution control, and manage the air pollution. Now, how do you diagnose the non-compliance to air quality? for cities. Now we need to see the exceedance of particulate matters, fine particulate matters like PM10 and PM2.5 concentration exceedances, that is long-term concentration exceedances through ambient air quality data. Now we can see that for 4 years, this is a typical city where the PM10 concentration this is a typical city where the 4 years of long-term data has been observed, and it is seen that this is exceeding the PM10 for the CPCB standard of 100 microgram per meter cube. So this shows that the city is having non-compliance towards PM10. Similarly, if we see the long-term air quality data for PM2.5, if it is exceeding 60 microgram per meter cube, that is the CPCB standard, then we can say that it is exceeding, it is the non-compliance towards PM2.5. So these are the various aspects for estimating the non-compliance. Here, doing this study in our country, more than 100 cities have been identified as non-compliance to air quality, where the city action plan and the air quality management has to be provided. Now, for any city action plan, the first thing needs to be done is a scientific analysis of the air pollution sources and its contribution to the air quality. So how do we do it? The source identification of air pollution is done by two techniques, that is emission inventory and identification of sources, and source apportionment study through chemical characterization of particulate matter. Both these studies can be done by two approaches, that is a top-down approach, which is a very a rapid approach of doing this study, that is by estimating the population we can do this study, or the road estimation, the traffic estimation. And the bottom-up approach, this is by identifying the activities of air pollution sources, right from small to big activities, and then identifying the emissions through that. The emission inventory is done by estimating the emissions in the present, projected and improved analysis. While doing that, like if most of the studies has been done for the year 2018 or 19, so the present scenario will give 2018. The projection will be there for 3 to 4 years beyond that, and the improved scenario will be through putting up air pollution management plans, so that we get an improved in the projected emissions while putting up the action plans. So how do we estimate the emissions? The emissions are estimated with a unit of kgs per day of PM10 or PM2.5 or gases. This is estimated by multiplying the activity, like a point source activity or a line source activity or the area source activity or a fuel use, multiplied by the emission factor. These emission factors are given by either CPCB or US EPA or European agencies also. So we are taking the CPCB emission factor and estimating the emissions from all the sources. Then apart from this, there is another option we can do by source apportionment studies. These studies takes into account the characterization, the chemical characterization of the particulate matter that is being monitored through sampling at various places in the city, and then identifying the sources through chemical characterization. Then how do we do it? This is a scientific analysis for estimating the cause of air pollution. This is, after doing this study, we give measures, that is a mitigation options, that is city action plan, measures for point sources like power plants, waste incinerator, etc. Not only end of pipe but also some comprehensive measures like clean fuel, clean technology. Measures to vehicular sources, consider technology, regulatory, economical measures by cooperation of concerned agencies like fuel change, road, traffic management and modal shift. Measures to area sources like road dust, open burning, fuel and domestic sector, and regulatory approaches, etc. So these are some of the measures we give. We also provide contingency plan for emergency situations, especially in industries, by giving alert system to the citizens. Also, like Delhi has a GRAS system for alerting as the air quality index changes. So that can be done. This is done by real-time monitoring data. Some preventive measures like land use plan, traffic plan, etc. can also be done for the abatement of air pollution at local level. Now coming to a particular example of emission inventory of sources for present, projected and improved emissions. Now take an example of road resuspension of dust. The emissions from road resuspension from paved and unpaved roads are estimated based on the road length and emission factors. The proposed length of roads for each type with time to achieve intended targets is also used for arriving at the emission reduction from strategic plan. So we have seen that through paved roads and unpaved roads based on the emission factors for 2018, then 19, 20, 21 and 22 based on the business as usual scenario, the growth rate taking as the BAU scenario, we have seen that it increases as per the paved roads condition. But unpaved road condition can be given some improved scenarios like paving those unpaved roads, and we can just do the paving and start the reduction of emissions from the unpaved roads through various pavements and doing concretization of the roads, and ultimately we can see that through the unpaved roads it has reduced a lot. Similarly, for the control scenario, if we see for the paved roads with sprinkling of water, sweeping and reducing the resuspended dust, we can do a short-term control also, and for the unpaved roads also we can do the short-term control. So these are the controls and these are the city action plan that for a road resuspension dust. Similarly, for construction and demolition waste, the emissions with the annual growth rate of 3% has been estimated with the business as usual scenario of this, and also with control measures following the MOEF guidelines with 20 to 50% reduction, then it will reduce up with this in the projection scenario also to this. So this is for the construction and demolition waste. Similarly, for cooking fuels, we can see that there can be a shift from the other solid fuels to kerosene to LPG and electricity or natural gas or solar. So through in the improved scenarios it will reduce. Now here what we have seen based on the number of households and the survey, we have seen that this is the distribution of fuel that are used for cooking at commercial and residential areas, and based on the consumption, the PM10 and the PM2.5 emissions have been estimated. Similarly, for the cooking fuel, we have seen that the projected emissions can be reduced to a certain extent by providing LPG and biogas, like for 70% by 2019, 75 by 2020 and 80% by 2021 to the targeted population. This is the baseline of 2018 that I am talking about. So the inclusion and the penetration of Ujjwala Yojana also has largely benefited this area. Similarly, the emissions from open burning, crematoria, then stone crushers as area sources have been, and slum areas have been projected for PM10 and PM2.5, and it can be seen that for stone crushers through various controls of long, small, medium and long term, we can reduce it from 1.8 to 1.2 and 0.8. And also the PM2.5 emissions of stone crushers can be reduced through various end of pipe treatments that is given in the action plan. Then for open burning also, it is for slum area open burning we can introduce LPG and then reduce the emissions. For crematorias we can introduce electric or green crematorias or gas fired and reduce the total emissions of the existing. And now for vehicle emissions, we need to take the RTO data of all types of vehicles for various years and project the data for another years, and then this value is being taken for estimating the emissions from various type of vehicles like two-wheeler, three-wheeler, four-wheeler, trucks and buses. For them, the existing 2018 PM10 and PM2.5 emissions is being estimated, and based on the projected value, the projected emissions are also being estimated for and the projected emissions with the control strategies, so 30 to 50% emission reduction through all these techniques. This is also estimated for improved emission scenario. Now, having done that, we come out with a total contribution in the emission inventory for all these emissions in terms of PM10 and PM2.5. And for this city, particular city, we have seen that the road dust is contributing 24%, industry as 27%, vehicle 7%, construction 14%, and other activities. This is for PM10. Similarly, for PM2.5, 16% coming from road dust, 17% from vehicles, industry 34%, 10% from construction, 10% from construction and other activities. So, this is the overall emission contribution from PM10 and PM2.5 for a particular city for a particular year. So, from this overall we can find out the grid-wise emissions also for a particular city, or a ward-wise emission, and we can identify these red ones are the priority areas or the hotspot regions of the city, followed by this orange color and yellow color, green being a good air quality level. So, this red ones needs to be taken in priority, and all the sources, point area line sources need to be addressed first, followed by this. So, the money that is being received can be started with priorities on these action plans for these areas first, so that we can see large amount of reduction in the air pollution, because we are tackling the hotspot regions. If we compare the emissions between the present 2018 and the control 2022 with implementation of city action plan for various sources for PM10 and PM2.5, we can see that for industry we can come down from 7.6 to 1.5 with various end of pipe treatments, then performance assessment using clean fuel and clean technology. So, mostly the pollution control board will be responsible for tackling up this in reduction of these industrial emissions from each cities. So, whichever industry is not having any control needs to be seen properly, and thorough end of pipe control has to be given. Others have to be seen for their performance assessment, and then improvement has to be done. Some clean fuels or clean technology, if feasible, can be given to some industries. So, similarly, by doing such activities, we can see that by long term controls we can see that this can be brought down. The emissions can be for industries. The Pollution Control Board, the industry associations, and the state and the central government are responsible stakeholders for this sort of source control. Then for vehicle also we can see that there can be good reduction of emissions from the present to the long term, mid-term and the long term control. Now, don't go by the year, because this study has been done for 2018, so long term is 2022. If some study is done today, then we can estimate similarly mid-term and long term. So, coming to the vehicle, we can see that there is a lot of action plan that is given for vehicle, and the RTO, the Road Transport Organization, the other organizations like state and the central level related to vehicle movement and vehicle activity, and also the vehicle manufacturers, they are all responsible collectively for, these are all the stakeholders who will be responsible for collectively reducing the emissions from these. Plus also the modal shift from metro or the electric bus or the CNG, electric vehicles and the CNG vehicles can also give drastic reduction on these emissions from vehicles. So, there is a need for stakeholder engagement for all these activities amongst the source reduction. Then coming to the road dust, mostly the ULB and the PCB and the RTOs, they are responsible for reduction of road dust, maybe through mobile sweeping or sprinkling or green belt or traffic intersection control. So, a lot of controls are there for road dust. Similarly, for cooking fuels, the modal shift from clean gas, from wood or kerosene to clean gas or clean fuel like LPG, etc. penetration needs to be done. So, the corporation, the revenue department, the fuel supply department, they are all responsible. Plus the citizens who use this fuel, they are also responsible. The restaurants, the bakeries, the small units, eateries, open eateries, they are all responsible as a collective responsibility of the stakeholders. Similarly, in the MSW dump site, there will be a reduction through various techniques, like there can be some waste heat recovery boilers for taking up the gas. Then there can be some MSW dump site improvement through plantations. Then MSW gas gathering and suction and treatment units can be taken into consideration for reduction. So so many techniques are there. Then for crematoria also we can introduce green crematoria, as NEERI has done some work on that. And then we can use gas and electric crematoria for reduction of emissions. For open burning, it is citizens' responsibility for reduction of all this open burning. We need to stop or ban open burning activities. For stone crushers, again the Pollution Control Board or the Revenue Department are responsible for end of pipe treatment, like back filters or multicyclones at the conveyors or the handling units of the stone crushers. For construction waste, all the guidelines of MOEF needs to be followed. The municipal bodies and other the construction private industries, they are responsible for this. So they need to take care of the road development organization and all. So these are the various control options and the stakeholders that needs to be engaged for implementation of this. Similar control actions are there for the PM 2.5 also, and the stakeholders needs to see that the controls have to be implemented. Having implemented the controls, we have to do the air quality monitoring before and after the control to see that we actually observe the values of reduction and provide the data to the public platform. Now another study, apart from emission inventory, there is another study, that is source apportionment, and the major component of source apportionment is particulate matter characterization. This is done through monitoring of particulate matter like PM10 and PM 2.5 through the techniques of regulatory techniques of CPCB through gravimetric analysis, and after the filter paper is exposed, the PM10 and PM 2.5, these are characterized for all these species. So these are alkali metals, these are the anions, the cations and the heavy metals that are there in the filter paper. These are analyzed at various locations that are being monitored. These are also analyzed for organic carbon, elemental carbon, sulfates, nitrates, ammonia, sodium and chloride. So having done that, we come to know that there are, so how do we do it? The elemental analysis, like so many elements, this is done by XRF or ICP-MS, or the ionics, the ions, that is anions and cations. These are the anions and cations that are analyzed. This can be done by ion chromatograph. And carbon analysis, like organic carbon, elemental carbon and carbonate carbon, these are analyzed by the TOR, TOT, ECOC analyzer. So how do we identify the sources? These are by organic markers. So these are the organic markers, and these are the type of sources that can be identified through the presence of these organic markers. Like for biomass burning, if we see the levoglucosan in the particulate matter, then it is biomass burning. If you see retin, then it is wood burning. If PAHs are observed to a high value, then it is through wood smoke. If phenanthrene is there, that is a suspended street dust and combustive sources. If aromatic and non-aromatic hydrocarbons are there, then it is gasoline and diesel. If piscine is there, it is coal. Similarly, if hopanes and stearins are there, it is a vehicle refined petroleum products. So these are all the organic markers. These also we analyze in the particulate matter to identify sources. Apart from these organic markers, there are others like potassium to OC or potassium to EC ratio. If it is 0, then it seems that the fossil combustion is there. It reduces, it doesn't give any combination like that. Then if EC to OC, if OC to EC ratio ranges from 1 to 4.2, then it is gasoline or diesel powered vehicle. And if sulfate to nitrate ratios greater than unity during winter indicates significant contribution from vehicle exhaust. if the average chloride to sodium ratio greater than 10 in both 10 and 2.5, then compared to seawater ratio of 1.8, it implies the anthropogenic emission of chloride ions, that is metal processing or chemical and dyeing industry. If high CM characterized by typical dust sources such as unpaved roads and open roads, then zinc to aluminum ratio is assessed. So these are all the various techniques for assessment of sources through particle characterization. So having done these studies, these are the various results of PM10 and PM2.5 source apportionment, like for Bangalore, for Delhi and for Pune. The PM10 mostly it is coming from the paved roads. Here also you can see that the paved road and soil dust are contributing largely to the air pollution, but in Delhi it is the other activities and the transport related activities that is providing the sources for the air pollution. Similarly, for point 2.5 for PM 2.5, for Bangalore it is transport activity, for Delhi it is paved, unpaved and other activities, and then for industries it is for Pune it is again the paved, unpaved roads as well as industries and DG sets and others are contributing to this activity. What happens when these sources get released in the atmosphere? It goes to a pathway and then settles down. So their atmospheric activity like wet deposition etc. takes into account. Then also the solar or the photochemical oxidation takes place. There is a dry deposition. Changes in the roughness also generates lot of complex activities of the pathway. There is a dispersion around the buildings right close to the point of origin. Then what happens, these all the things they takes into account as a dispersion parameter for various sources, like point sources coming from stacks or vents, area sources from landfill, ponds or from combustion activities, storage, piles, crematoria etc. For line sources it is traffic, conveyors etc. So all these sources when they come out, they pass through a pathway. In the pathway they undertake chemical reaction, dispersion, neutral or dense gas reaction, deposition, volatilization, condensation and nucleation of aerosols. This is a pathway activity, and then it goes to the receptor and settles down, deteriorating the residential, commercial and industrial infrastructure, traffic intersection, indoor air quality, chemical characterization changes, and health impact is also because of this receptor deposition at the receptor. Then how do we estimate the action plan? Since it is moving around, it's not static, it is dynamic system, so we have to have a dynamic action plan also. So our action plan is divided at source, pathway and receptor. So at source, then we have to give the source reduction aspects of the industries, thermal power stations, vehicles and area sources. Now for the small scale and the medium scale industries, at present they should aim at zero pollution through installation of appropriate scrubbing units, filters and clean fuel or technology. So the pollution control board are responsible for this. For large scale industry also, the performance efficiency of ESP and APC should be strictly adhered through regulatory audits. Even the IUR should take active participation in this. The coal-based thermal power station and the CPP boilers, furnaces should install FGD and DNOx system as per the regulatory guidelines. The PCB needs to coordinate for this. Old excessive polluting vehicles to be phased out periodically. Here again the state government and the central government as well as the vehicle department needs to coordinate. The state of art exhaust emission control to be fitted in all types of vehicles fit for zero pollution, like catalytic converters or other sophisticated pollution abatement devices. Electric vehicles and CNG vehicles and mass metro and mass transit to be encouraged. In most of the cities we have started, and also in large scale now electric vehicles will be coming in the NCAP program. that is a welcome thing. Emission control from open fire crematorias to be controlled through green belt, through green crematoria, effective suction and scrubbing, electric and gas based furnace, etc. Then the MSW dump site should have gas gathering station and effective use of fuel. Then the waste heat power generation system may be installed in the MSW dump site. In the pathway control at major polluting nodes for cleaning the polluted air, we should regulate the traffic based on the ventilation of atmosphere. They should plant dense green belt in polluting corridors, traffic corridors and flyovers, water sprinkling and fountains at dusty roads, air pollution control units at traffic intersections, smoke tower, Vayu, impact filters, etc. to be encouraged and used. Controls at flyovers to reduce the line source polluting emanating at increased height with effective suction and intermittent and scrubbing to be used for with both dry and wet. Regular paving, cleaning of roads and roadsides for frequent removal of garbage through manual or mobile sweeping machines. Construction activities to be done with zero pollution impact on atmosphere. Providing pathways for cycling and walking and giving incentives. Installation of polluted air suction and exhaust system in traffic corridors, and regular paintings and hoardings for treatment of gaseous pollutant. Now at receptor control also we have to see that large amount of controls to be done by restricting vehicular growth, controls at major polluting nodes by cleaning the air by effective intersection emission control, traffic regulation, all the meetings through online, movement of trucks, buses to be avoided in the city center, and rationalizing the ownership of usage of private cars, carpooling in school offices, regular monitoring of AAQ in hotspots with and without control, hotels, hospitals, restaurants to strictly use electric or solar energy for canteen, increased use of solar energy in corporate offices, hotels, restaurant, malls, ban reduced DG sets in shops, offices, malls, etc., and ban open burning and provide support to weaker sections for their combustion or the cooking requirement. Now these are the various stakeholders. As I have already told, for each action plan there is a stakeholder which needs to be strengthened properly by technical and financial assistance. The functions of these stakeholders are to conduct several meetings amongst themselves and then coordinate for implementation of these action plans, formulate appropriate policies and develop legal systems, strengthen administrative organization to ensure the effectiveness of implementation, financial assistance and periodic review for with feedback for effective implementation. This needs to be done, and ULB should be the coordinator for regulators, state and central government officers. Those are responsible for undertaking the city action plan implementation. The private sector NGOs also have a greater role in providing partnership for introduction of and modernization of these city action plan technologies. Then awareness raising through mindset changing, environmental education and other activities. This needs to be done. The citizens also are responsible for cleaning the city area by providing support to the ULB and other stakeholders. The research and academic institute should enhance the capacity and provide technical knowledge timely to this all ULB and other state departments. The stakeholder engagement will enhance coordination among public departments also, and the PUC, that is in use vehicles, should be very effective. Now the remote sensing techniques are being used and that needs to be developed properly, and these RTOs and this needs to be strengthened. The private PUC centers needs to be strengthened for proper calibration of such systems. Independent fuel testing laboratories should be developed for checking fuel adulteration, and this needs to be like these laboratory instruments needs to be calibrated. Use of clean transport fuel, that is CNG or electricity, may be used and that is encouraged. Effective public participation in most of the meetings to be ensured. So these are all the various things that has to be done for stakeholder coordination. Now if we see some of the city action plan, we can see that for area sources like bakeries, hotels, restaurants, These are the control options like use of LPG, clean fuel, electricity, ban on the open throwing of waste, open burning of open burning of plastic, and proper collection and disposal of waste. So this will reduce the emissions. It's a long term or a medium term action plan of 10 to 15 months, and the responsible agencies are ULB, PCB, district collector, etc. Similarly, we have for domestic fuel combustion, burning, crematoria, construction, demolition waste, and DG sets. These are all the control options that I have already told, and these are all the responsible agencies with time frame target. So funds are also being provided. I am not showing the funds, it will be taken up in a separate session. So funds also needs to be spent, or the expenditure may be shown based on the time frame only, and also with a periodic review and the performance of the implementation program. So these are all the various responsible agencies for the control from various sources. Now similarly for vehicles, the control options are inspection and maintenance, use of alternate fuel, restriction of commercial vehicles in city, fuel adulteration improvement, electric operated vehicles, remote sensor based PUC system. So these are all the reduction and the implementation targets. And the Transport Commissioner, RTO, Ministry of Road and Surface Transport, then city district collectorate, anti-adulteration cell, oil companies, DCP, transport office, etc. are responsible agencies as stakeholders for this activity. Now again continuing for vehicle, through public awareness program, this NGOs should also take part apart from ULB and RTO. Then parking of vehicles, here also at non-designated areas, here also citizens' role is there, NGOs, municipal corporation. Then greening of open gardens, here the garden department of the corporation needs to be active in this. Now for all the technical assistance should be given by IUR, and the other academic institute should participate in a large activity through internship of their students and doing the activity, so that a scientific output is generated for such study. Now again for vehicular emissions, widening of roads, pavement improvement, use of dust control agents like smog tower, Vayu, etc. for dust reduction, and these are all the departments who will be responsible for the functioning of these units. These are some of the examples or case studies that we have done, like a mobile emission monitoring and control lab is developed by CSIR NEERI, wherein we have emission monitoring and emission control units that are designed in the van. Here this can be used for industrial emission monitoring and control. PCB and industries and research institute can use it. Then resuspended dust mitigation at roadside and traffic intersection can be done through this. Then emission control at SSIs and area sources can also be undertaken by this, and emission monitoring and control at MSW dump sites, this study can also be undertaken by this. We have undertaken such study in a thermal power plant for a pilot study on flue gas desulfurization, and we have seen that there is a drastic reduction in the emissions of acidic gases from using various scrubbing liquids in our mobile van. Similar study has been done by using dry filter bed reactive system in a traffic intersection at Nagpur, in Shankarnagar and Sadar area, and we have seen that for 10 days this filter bed is very active, and it has reduced 90% of the inlet dust load and given a clean air through it. And this can be seen by that apart from dust there are other gases also which has got reduced. After 10 days this reactive bed can be taken up for regeneration, and that can be reused after its regeneration. Similar study has been done for crematoria, where we have seen that we have monitored the crematoria emissions just above the cremation and in the surrounding, and we have seen that there are a lot of emissions that are coming for various gases as well as dust. And pilot study at Nagpur and Nigambodh Ghat, Delhi has been put up, and we have seen that about 70 to 80% reduction in dust and gases is seen, which has given the environmental benefits of air quality improvement, reduction in exposure to population and overall air quality air pollution reduction in the surrounding areas. One study has been done for MSW dump site also. This is through our mobile van, wherein we have monitored the organic gases, about 50 number of organic gases we have monitored in the open dump site, and then we have tried to control through our mobile van. It has seen that nice controls have been provided, so this can be used in the MSW dump site also. One more important aspect is a modal shift in transportation that we can see in a Delhi metro sort of example. We can see that over 200 kilometer long mass transit public transport is there with nearly 3 million passengers per day. This has given a large reduction in vehicle numbers in the city, and fuel consumption is also reduced drastically with a reduction in pollutants. About 5,77,148 ton per year of pollutants have been reduced. Overall pollution like dust and gases. Even some use of clean fuels can be there, like gasoline plus ethanol, CNG, hydrogen, diesel and electric vehicle can reduce the emission to a large extent. Thank you, and that is the quest for clean air. Thank you.